what is the difference between earthquake magnitude and structural damage? Imagine feeling a shake that makes your house rattle or your windows rattle. That's what people experience during an earthquake, but what actually causes that shaking? And how do we measure how strong an earthquake is versus how much damage it causes? That's what we're here to find out. Earthquake magnitude is a number that tells us how much energy was released during an earthquake. Scientists measure this using special instruments called seismographs. They give us a single number on a scale, like the Richter scale or the moment magnitude scale. The higher the number, the more energy was released. For example, a magnitude 3 earthquake is small and usually not felt by people, while a magnitude 8 earthquake is extremely powerful and can cause widespread destruction. Now, structural damage is all about what actually happens to buildings, bridges, roads, and other structures when the ground shakes. It depends on many things, like how close you are to the earthquake's epicenter, what kind of ground your building is on, and how well the building was built. Even a moderate earthquake can cause serious damage if the structures are weak or poorly built. Here's an interesting point. A very high magnitude earthquake does not always cause a lot of damage. If that earthquake happens in a remote area with few buildings, it might not do much harm. But if a moderate earthquake hits a city with old or weak buildings, the damage can be severe. That's because the strength of the buildings and how they're designed to resist shaking play a big role. So, in simple words, earthquake magnitude measures the total energy released by the quake. Structural damage shows the actual harm done to buildings and infrastructure. The two are connected but not directly. A big earthquake can cause little damage if the area is unpopulated or well prepared. Conversely, a smaller quake can cause a lot of destruction if the structures are not built to withstand shaking. Understanding this difference helps us prepare better. We can't always control how strong an earthquake will be, but we can improve building standards to reduce damage. That way, even if the earth shakes hard, our homes and cities can stand strong.